Hello everyone. Today we are going to talk about the chapter 9, Cratered words. We'll primarily discuss two objects in this chapter, the moon and the planet Mercury. The reason we want to put these two objects together is because they share a lot of similarity. You can see in this picture, one is the moon, one is Mercury. Can you guess which one is which? At least you can see from these two pictures they share a lot of similarity. The major similarity you can see here is their surfaces are covered by craters. And you can see, unlike the Earth, you cannot see any clouds or the evidence of atmosphere. And they looks like they are primarily, at least on the surface, you can see they are made from rocky material. Do you already have the answer for my previous question? Which one is moon? Which one is Mercury? If you look at the size, the moon is actually smaller and Mercury is actually a little bit bigger, but Mercury is still the smallest planet among 8 major planets. We will talk about the moon first, then we'll discuss the detail of Mercury. Let's first look at the property of the moon. When we look at the property of the moon and the rest of the planet, we'll try to compare it with Earth. So you can see here, if the mass of the Earth is 1, the mass of the moon is about 0.0123. So it's only in terms of mass, the moon is only like 1% of the mass of the Earth. About the size, the Earth's diameter is about 12,000, so the moon's diameter is like about 3,000. It's around like 1/4 of Earth's diameter. For the density value here, if you look at the density value here, remember when we talk about the Earth's density value is about 5/5,000. And if you still remember previously, we mentioned the Earth made from rocky material and near the core is actually with high density metal. So you can see the density of the moon is significant smaller compared to the density of the Earth. So at least we know there are major differences of the composition of the moon compared to the Earth. And because the moon has less mass, and therefore the surface gravity of the moon is only like 70% of the Earth. So therefore, if you travel to the moon, you're able to jump very high on the moon because there's less gravity. As a result, to escape the gravity of the moon, you are going to need much less escape velocity. So it is easier to basically, if you think about launch the rocket ship from the moon. At the same time, that means it's also easier for the air to escape from the moon's gravitational pull. And the orbiting period of the moon, that is how long it takes the moon to orbit once around Earth, is 27.3 days. If you notice that these two numbers, the rotational period of the moon is actually, that means how long it takes the moon to rotate around its own axis, is also 27.3 days. So that means the orbiting period and rotation period is the same for the moon. Therefore, if we look at the moon on the Earth, we'll only always see one side of the moon. So that's what we call the near side of the moon. And the far side of the moon is always facing away from the Earth. So therefore, if you want to look at the far side of the moon, you're going to have to send like a spacecraft to go all the way around the moon to take pictures. As a result, the smaller size results the smaller surface area of the moon. And finally, the surface temperature of the moon is more extreme. I mean, the lower temperature is much lower and the high temperature is much higher. Just give you some reference. So the surface temperature of the moon can be as low as 114 Kelvin. The typical room temperature on the surface of the Earth is about 300 Kelvin. The water freezes about 273 Kelvin. So it's actually much, much colder than the coldest temperature we can have on the surface of Earth. But when it's become very hot, 400 Kelvin, the water actually boil at 373 Kelvin. So the highest temperature actually on the moon is even higher than the boiling point on the Earth. So you can imagine it's definitely not comfortable and to live on the moon because it either get too hot or too cold. Remember, those numbers are for the equator of the moon. If you travel to the north pole or south pole of the moon, the coldest temperature, the lower temperature, will even colder. So you can imagine that water will be basically freezed at this temperature. And based on some of the number of the properties as well as some samples we actually take from the moon and we study from the moon, you can see the moon is actually, we found the moon is a severely depleted in both metals, a volatile material. In terms of a metal material, you can see, we know moon's density is comparable to the density of the rocky material, which is like 2,600. So this is actually have very little or almost no high density metal. Volatile material represents the material can evaporate at low temperature. For example, the oxygen, nitrogen, or water. And because you can imagine, the surface temperature of the moon is extremely cold during the cold period of the time. So all this material will be basically, a lot of material will be basically freeze. However, when it gets hot, it can get very hot. So in terms, if you think about water, water will basically at 400 Kelvin, water will basically evaporate. So they will evaporate as water vapor. And also because the moon has much lower surface gravity, as a result, the volatile material, or you can imagine the gas like oxygen, nitrogen, what we have on the Earth, hydrogen, helium, and even water vapor, they can escape easily into the space. And so therefore, the moon actually have no atmosphere. And later on, we'll also talk about the atmosphere on the other planets or other moons. There are actually three important reasons to determine if the object can keep air around. For example, as you may all know that air molecules tend to move around easily without like restriction. And with the higher of temperature, you can imagine their molecule can easily move faster and faster. As soon as the air molecule's velocity or speed go over the escape speed, the molecule will escape into the space for good. And other than that, it also depends on how heavy is the air molecule. For example, what we have on the Earth is oxygen and nitrogen, which are all pretty heavy air molecule. Unfortunately for the Earth, we are still not have enough gravity to keep helium and hydrogen around, because for light molecule like helium and hydrogen, it's more easier for them to escape into the space. The bigger planet later will learn that, for example, Jupiter and Saturn, they are big enough. They has much higher gravity, so they can basically keep the lighter gas molecule or air molecule around, for example, hydrogen and helium. And also, when you look at the moon, there's no magnetic field. If you still remember that when we talk about the Earth, the two necessary requirements for the object have a magnetic field is the first, it has to have what we call the liquid molten metal core. So that is where the free charge or electron come from. The second, you will need to have rotate around itself. So you can see for the moon, it meets the second criteria, it rotates around its own axis. However, the depletion of the metal means the moon have no iron core. So therefore, there is no magnetic field for the moon. We'll still use the similar criteria later when we talk about other planets. So based on what kind of, if they have like liquid metal material at a core, as well as how fast the object or planet rotate or spin around its own axis, we can basically determine whether they have magnetic field or not, if the magnetic field is strong or weak. As we talked about, based on the density of the moon and of course as well as our observation and the sample we took from the moon, we know the moon is made primarily of almost entirely of the silicas, basically the rocky material, which really like those in Earth's mantle and the crust. And if you look at this rotation moon, the 3D model of the moon, you can see a majority of the part is covered by the crater. It looks a bit lighter in color. And you are able to see that actually on the near side of the moon, we actually have a large dark region. And we call this dark flat area. It's actually created due to lava flow very long time ago. We call it the Maria. The reason why it has its name is because before people landing on the moon, or at the very beginning when we see this dark flat region, people on the Earth thought it might be a sea on the moon, so we name it as the sea in Latin. And the lighter area is actually elevated areas, and because they are higher, and you can see there's a lot of craters on the lighted elevated area. We call the highlands. And there, you may imagine we are so interested in those nearby objects. Moon is one of them. We even send people on the moon. And of course, is one of the most important thing people think about is that if the moon can be a habitable place. For example, in future, if we want to establish a space station, a station on the moon, can it sustain itself? One of the most important thing about a habitable place is if it has water. And we already know that the moon has no atmosphere. Unfortunately, there's no way we can breathe freely on the moon. However, the next, we definitely will need to bring the oxygen, or there are some ways we need to create oxygen on the moon for us to breathe if we want to live on the moon in future. Another most important is that we will need to look at if there's any water on the moon, because we also need to drink water on the moon, and it's gonna be impossible to always transport water from the Earth to the moon in future if we want to establish a settlement on the moon. And NASA actually did a very interesting experiment. It actually led a spacecraft to orbiting around the moon. At some location, the spacecraft and sent an object to actually climb on the moon. As the object climbed on the moon, there was gonna be some debris will actually go from the collision site, go into the surface and go into the place or the region above the moon. So the detector look at or do the analysis of this debris come from the collision. They actually found that there is chemically bonded water in lunar rocks. So that means we can use certain way to extract the water from a lunar rock. And they also found some water ice in the permanent shadowed craters near the lunar pole. So you can see this can all be the potential source of water for us in future when we want to establish settlement on the surface of the moon. You may know that most of what we know about the moon actually derive from the Apollo program. You can see there's a lot of images from Apollo program give us opportunity to get a closer look at the moon. You can see this is a big rock of the moon and astronaut is nearby. We even put an American flag on the surface of the moon. And you can see that is basically how the lunar surface looks like. Other than those pictures or images provide very important information of the moon, the program also bring back about 400 kilograms of lunar sample at different locations of the moon to the Earth for us to study them in more details. And so therefore we can know more about the moon. For example, we can use the radioactive rock dating to date the age of this lunar rocks or lunar sample, and we can also look at what they are made from, and they can review some important hidden information about the moon. In terms of Apollo program, is starting from 1968 from Apollo 8, which start to orbit around the moon, to Apollo 11, you may heard about the human being first step on the moon, and all the way to Apollo 17, which is in December 1972, sent basically to now the last human step on the moon. And the program is actually ended after Apollo 17. And in total, there's 9 piloted spacecraft, and in those 4 years, and in total landing 12 astronauts on the surface of the moon. And the astronauts actually carry a lot of different experiments and a mission to explore the surface of the moon. One of the most famous or most interesting experiment astronaut did on the moon is the hammer-Earth feather. We already watched this video when we talk about the gravity. Now I want to show you the video again. This time I want you to focus on the differences on the surface of the moon compare what we have on the surface of Earth.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. I have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that? Proves that Mr. Galileo was correct in his findings.
Okay, you can see at least some significant. So you can see here, all the astronauts on the moon are wearing the spacesuit. They of course there's a couple of reasons. One you can think about because it's extreme, either cold or hot temperature. And also there is evidence there's no air on the surface of the moon. If you hear the sound, the sound is not directly from the astronauts, the vocal cord. Instead, they are communicate with radio because sound actually need a media to propagate. So there's no air on the moon. So therefore, even you shout on top of your lung, nobody can hear about what you're talking about. So therefore, they actually use the radio to communicate. And you can see all the astronauts actually wear the helmet because they make sure they have oxygen inside their helmet they can breathe. So you can see there is just by looking at the video, there's evidence that there's no, at least a breathable atmosphere on the moon. And when the hammer and the feather reach the ground at the same time, if you do the same experiment on the Earth, they probably will not reach the ground at the same time, because on the Earth we have air friction, but there's no air on the moon, therefore makes the moon the perfect location to test. And this also, if you look at maybe at the beginning of the video, the astronaut able to kind of hop on the surface of the moon, despite they are actually wear very heavy spacesuit. This is because the moon's gravity is much lower, so therefore, even with very heavy load, they can kind of hop around. So you can see this short video actually have a lot of information about the moon. The end of Apollo program is actually not ending of the exploration of the moon. Actually, about a half century later, NASA actually restart the lunar exploration program, and we expect to send people again on the moon. And this program is called Artemis program. If you're interested in the Artemis program from NASA, you can definitely get more information from NASA website about the program. And so far, we already sent the Artemis 1, which is an unmanned mission to orbit around the moon to test if the technology works. In the next phase, we plan to send a few astronauts to the moon to resume our exploration of the moon. Now I want to share the video with Artemis 1 moon mission, which was actually launched 2022.
Our return to the moon will be different than the last time. We plan to explore more of the lunar surface and
the space launch system is now counting down to liftoff of Orion on its maiden voyage to the moon. And here we go. Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
We are all part of something incredibly special, the first launch of Artemis.
This view of Earth from a human-rated spacecraft not seen since 1972 during the final Apollo missions.
Distant retrograde orbit. We're going to be about 38,000 miles away from the lunar surface. We're going beyond anywhere we ever went for Apollo.
The Orion spacecraft is barreling its way back home after circumnavigating the moon and beyond in an elliptical distant retrograde orbit. Splashdown. Orion back on Earth.
Now I want to share with you a video. It's Artemis 2, so the next step of the mission. So this time, NASA planned to put astronaut actually inside the rocket ship. If you can see the reason we want to resume, one of the reasons one will resume the exploration of the moon is because Artemis mission actually could set as a stepstone for us to finally fly and land on Mars. And this is actually very exciting program. If you keep your eyes on NASA's news, you'll get all the updates about different stages of the program. Now let's take a close look at the lunar surface. And because we mentioned Apollo mission actually brought back lunar sample, and therefore we can do the radioactive dating to know or to get information how old is those lunar rocks. And by doing that, we actually estimate the moon similar at Earth was actually formed about 4.5 billion years ago. And for the rocks, when we do radioactive dating on the rocks are from the heavily created highlands. They are actually older. They are about more than 4 billion years old. And the rocks from the darker volcanic plain of Maria, which once flooded with lava, was actually a little bit younger. And therefore we believe the Maria was erupted, the volcanic plain of Maria was erupted primarily between 3.3 and 3.8 billion years ago. If you still remember, that is one way we kind of estimate the age of the rock or the surface. Remember the age, we define the age of rock or the surface is from the last time the rock is solidified. So basically, whenever the rocks or the surface is molten or is a liquid or is changed by either tectonic or erosion force, we probably will restart the counting of the time. The other, if you remember, the other way we can estimate the age of the surface is by counting the craters. At the bottom, I have two images, one from Maria, which is darker, flat region, and which was once lava flow, and this one is a highland, which is lighter, higher elevation region. You can see that by counting the number of craters, at least look at the density of craters, highland, of course, has more craters than Maria. So again, as well, by counting craters, we know highland is actually older than Maria, which actually match up with the result we get from the radioactive dating from the lunar rocks. Now let's take a look at the a little bit other surface feature of the moon. So in this picture, you can see this is a lunar mountain. Can you see, is there any differences when you compare the mountain on the moon to the mountain of Earth? You can see the lunar mountain is pretty much smooth and actually do not have cliffs and sharp peaks. Can you think about the why? Remember when we talk about the Earth, for the Earth mountain, the reason they have cliffs and sharp peaks because there's the wind and the water or the ice erosion. So they basically can carve them into cliffs and sharp peaks. However, on the moon, remember, there's no air. So therefore, there's no wind. There is no liquid water. There's no water erosion. So therefore, the morphology or the appearance of the mountain on the moon will look very different from the Earth. And the most important feature on the moon, of the surface of the moon, is basically dominated by the impact cratering. And another consequence of the impact, because every time when there's an object collide with surface, it will, later on we'll talk about, it will trigger an explosion. Basically will blast rocky material into small pieces. So this, in addition to creation of a crater, this also produce is a very fine grained soil because of the impact. You can see there's a actually very thick layer of the soil and very fine-grained soil on the surface of the moon. And because there's no wind, so basically there's no kind of redistribution of these soils. And if you look at this bottom picture, that is actually a footprint left by an astronaut in one of the Apollo mission. The astronaut actually left a lot of footprint on the surface of the moon. You can see how thick is the surface soil, right? And I want to also ask a question. So how many years you can think about the footprint will remain on the moon, surface of the moon? If you think about on the surface of the Earth, if you left a footprint, it may not last very long, right? Because there's a lot of surface activity of the Earth. We have water. Whenever it's rain, the water will basically destroy the footprint. Or if we have the blowing of a wind, the wind will also blow away the soil that be part of a footprint. So if there's a footprint on the Earth, it won't be very long. However, remember, on the moon, there is no wind, there is no water flow. So basically, if those footprint is undisturbed, it can be on the moon forever. So, like, luckily, in future moon mission, when the astronaut land on the moon near the site of previous missions, they were still able to see those footprint left by Apollo mission astronaut on the moon. Again, if you remembered from studying the surface of the Earth, a lot of surface of Earth features are basically created by the plate tectonics. For example, the rifts, the ocean trench, the high mountains. However, when we look at the surface of the moon, there is no evidence of plate tectonics. No similar feature on the Earth that result from the plate tectonics actually able to found on the surface of the moon. So there's also indicate the mantle or the inner part of the moon is probably already solidified. Remember, the driving force for the plate tectonics on the Earth is the molten mantle that the plates, the crust plates, actually is kind of float on the molten mantle on the surface of Earth. And even the moon actually have volcanism, which produce Maria, the dark flat region. This is volcanism is not from the eruption of a volcano. You can see that we believe that Earth's tidal force on the moon actually and is the driven force of the moon's volcanism. It's not like one or two volcano eruption. It's like a large area that under the stress of tidal force start to melt. Therefore, you have the lava flow at a large area. This is not a result from the plate tectonics. Now I want to share with you a video about evolution of the moon, basically talk about roughly what time the highlands form and what time the maria form. You can see at the beginning, the moon is also kind of molten and very hot. And then it's a period, and then it cools down, so the surface is solidified. However, it's actually start to embrace the bombardment. Then later, after Maria formed, they're intermediate cratering, so therefore still we can see some craters on Maria region. You can see one of the features make the moon's surface very different from the Earth is the cratering. So now I want to take some time to look at more detail what actually creates crater and the feature of craters. And also you can look at until we have a close image of the lunar crater. There is also another case we can have some like concave structure similar as the lunar crater, which is the volcano. On the top of volcano, we can have the crater on the top of the volcano. One that is lava recede from the eruption will left this concave shape. And long time ago, at the very beginning, people think about the crater of the moon is actually produced by the volcanism. But once we get closer image, when we look at the overall feature of the lunar crater, we found that it has slightly different than the crater on the top of volcano. For example, if you look at the lunar crater, it's mostly on kind of flat region, and there's always have a center peak. You can see, and on the side, it looks like it have a little bit elevated region around the rim. So this is actually a typical feature or structure or impact crater. So which indicates this crater or the most of the crater on the moon, almost all are created by the impact of the object from the space. And what is the process of the impact that actually creates those craters? And one, a debris from the space is about to climb on the surface of the moon, You can see there's no air on the moon, so therefore there's nothing kind of to stop or burn out those meteors or asteroid that is heading towards the moon. So once the object collides on the surface of the moon, because it's actually kind of accelerate or speed up by the moon's gravity, the moment it crashed on the moon it's actually moving very fast. So the collision, the force of the collision were able to generate our wave or a pressure to which is pulverize these rocks. So basically we're able to shake or destroy the structure of the rock into small pieces. And at the same time, the collision, because it's generated a lot of energy, a lot of heat at the same time. For the collision will bring us some debris, of course, from the collision side, but at the same time, it will trigger a big explosion. The big explosion will basically generate more debris because the explosion not only of the impact the media, but also from the rocks surrounding or nearby. And then finally, those debris will finally land on the surface near the crater, basically will have a what we call deposit blanket around the crater. I want to share with you a video on what happens when an object is inclined on a surface with a thick, loose, fine-grained soil. You can see there's a large ejected material or ejectile. And finally, they will landing on the surface. You can see it again. So you will have a slight higher elevated rim as well as a large range of deposit material from the ejectiles. This video will basically use different color to color code the different layer of the soil. So you can see the impact will be able to bring the soil from the deep ejected into the area above the surface, and finally this part of soil will re-land on the surface. When you look at the steps of cratering, and because there's also a step that is actually explosion happen due to the high speed impact. Therefore, a typical crater created by the impact will 10 to 15 times the size of the media like the impactor. And the typical feature of impact crater is rise rims, we already talked about, and also there is ejectile blanket, and sometimes there is center peaks. If you see a crater with this feature, for example, the one from the previous image, for example, this crater, exactly match all the feature of impact crater. So therefore, that is a result of our impact. There are also some craters, if you look at on the moon, the one on the middle of Maria, you can see this star-like shape, right? That is actually the debris and ejected and then finally land on the surface. And if we look at the frequency of cratering rates, so basically the frequency of the bombardment, it is not actually even during the history. And for the past 3 billion years, it's at pretty low rate, or we can see pretty constant. However, during the time short after the solar system forms, we actually think about this, we call it the high rate formation of impact crater, because at that moment there is a lot of debris from the formation of the solar system and those debris are not yet clear into the region of Kuiper Belt, outer cloud, or asteroid belt. So those debris are actually freely kind of fly everywhere in the solar system, which result a very high rate of the formation of impact craters. Sometimes we call it big bombardment period before like 3 billion years ago. You can see this is roughly like from 4 billion years ago, right after the formation of the solar system. So as we also mentioned, the crater counts can be used to derive approximate age for geological feature on the moon. So therefore you can see the moon still maintain most of the craters. Therefore we know, at least compared to the Earth, the surface of the moon is much older. The next question we were wondering or will answer is the origin of the moon. If you look at the moon, it's actually a very special existence. If you look at the 4 terrestrial planets, Mercury, Venus, Earth, and Mars, there is no moon for Mercury and Venus. Earth only have 1 moon, and Mars only have very small moons. And for the Mars, because we believe that those 2 moons looks like asteroid, they may just by chance capture from asteroid belt from between Mars and Jupiter. So moon is actually a very special existence for the Earth among the 4 terrestrial planets. And at the very beginning, there are 3 early hypotheses for the origin of the moon. The fission hypothesis means that the moon used to be one part of Earth, but later on it somehow get independent. However, and most recently, the calculations show that this sort of spontaneous separation or splitting is almost impossible without any external force. And another theory is the sister hypothesis. The sister hypothesis said the moon formed together like independence of Earth, the similar as the formation of other planets. But the one problem for that is, unlike the Earth, there is no metal or iron core of the moon. If they all form independently, they should have gathered the similar type of material. And the third is a capture theory. They actually talk about the moon was formed elsewhere in the solar system and was captured by the Earth. But this also have a problem, because if it won't be captured by the Earth, first of all, Earth has very strong gravity, but Earth's gravity is not very strong compared to other planets. The second, the moon had to be slowed down significantly for Earth to capture that. So all these early hypotheses is all problematic. And the facts we actually know that actually by the looking at the lunar sample brought back by the Apollo mission, we do the analysis, we found there is actually a lot of similarity between Earth's mantle and the crust compared to the moon. We even have the identical fraction of some major isotopes than we can find in the lunar samples. So that's all indicate there's a very close relation between Earth's crust and mantle and the formation of the moon. So therefore, for nowadays, the accepted theory for the moon's formation is what we call the giant impact theory. So long time ago, about 4.5 billion years ago, the impact of Mars-sized projectile with the Earth, and then the debris from the impact made a ring around the Earth, and those debris finally condensed together and formed the moon. I want to share you with a simulation from NASA, basically kind of show you the process of the formation of the moon based on the giant impact hypothesis. So you can see this giant impact hypothesis actually explains the facts why the moon is kind of a special existence in the inner solar system for terrestrial planets, at the same time explain why the moon actually made primarily from a rocky material which lack the metals, because most materials actually come from the collision debris from mantle and the crust of the Earth. Now, finally, let's go ahead to look at Mercury. Let's first look at some property of Mercury. You can see the mass of Mercury is only about a little bit over 5% of that of Earth. We'll always compare them, but it's still higher than the moon. So Mercury is a little bit bigger than the moon, but Mercury is actually the smallest and the nearest planet to the sun, and therefore the fastest orbiting planet. The diameter is about 5,000, which is a little bit less than half of the Earth. However, the density is very close to the Earth, which is over 5,000 kilogram per meter cube, which also indicates Mercury actually has a significant part of iron core, because the rocky material cannot have such high density. Surface gravity is a little bit less than half of the Earth because it's smaller size and less mass, and therefore it's also easier to escape from the Mercury's gravitational pull. The orbiting period is the shortest. For example, on the Earth it's 365 days, but Mercury is only 88 days because it's actually closer to the sun. Remember, the closer to the sun, the faster it's orbiting around the sun. But if you compare the rotation period, it's basically how fast, how long it takes for Mercury rotate around its own axis, is actually much longer. It's 8.65 days. On the Earth, the number is just 1 day. So you can imagine a day on Mercury is super long, right? So when you talk to your friend, in case in future you fly to Mercury, see you next day, then you will basically wait for a very long time. And of course, because Mercury is smaller, the surface area is actually much less compared that to the Earth. We believe the orbital and the rotation period for Mercury, you can see there's a very interesting relation we call 2-to-3 ratio, that if you multiply 18.8 by twice, it's roughly 3 times of its rotation period, which is 58.65 days, which we all believe that is due to Mercury, since it's closer to the Sun, is actually kind of tidal locked or influenced by the tidal force of the Sun, which basically slow down its spinning or rotation around its own axis. And the surface temperature of the Mercury is even more extreme compared to the Moon. It can get very cold. Part of the reason is because the similar as the Moon, there's no atmosphere, there's no greenhouse effect to keep Mercury warm when there's no energy from the Sun. The other reason, also similar as the Moon, is that there's no water to regulate the temperature. So those rocky material, once they can actually cool much quickly. So therefore, when there's no sunlight, the region can cool down pretty quickly and reach a very cold temperature. However, even hotter compared to the Moon, that Mercury surface temperature can go over 700 Kelvin and on the side when it's facing the Sun. That means when there's a sunlight. One of the reasons you can think about, because Mercury, even it's the smallest planet, but it's nearest planet to the Sun. You will the unit area of Mercury when it's facing the Sun, so actually able to receive a lot of heat from the solar energy. So you can imagine that's why it can got very hot on the side facing the Sun. But the temperature difference is 600 Kelvin. It's just too much to be a comfortable place for a human being to live on Mercury directly without any way to regulate the temperature. So let's take a look at the two things. We already from the density, we know the Mercury have a significant large iron core, right? And also we know Mercury is orbiting and is spinning, right? Spinning around its own axis, but it's much slower than the Earth. So we want to think about if Mercury, do you think the Mercury actually has magnetic field or not? And how it compared to Earth's magnetic field. You can see actually Mercury do have magnetic field, but it's much weaker magnetic field compared to the Earth, because Mercury already meets the two criteria for a planet to have magnetic field. One is liquid iron core, the other is the rotation or the spinning. The reason the magnetic field is weaker is because the spinning or the rotation period is much longer. It's about 59 days compared to 1 day on the Earth. When you look at the picture, there's evidence there's no atmosphere. The reason why Mercury do not have atmosphere is similar as the Moon. It can get very hot. When it's hot enough, all the airs already move fast, so it's escaped from the gravity of the Mercury. And when it gets very cold, a lot of material will freeze into a solid form. And therefore, the Mercury, as small planets with weaker gravity and with a large variation of temperature, it's really hard for it to keep the air around. There is some level of past volcanic activity on Mercury when we look at closer. Also, water ice can be found in crater near the poles, the similar as the Moon. And also we have some unexpected discovery of some carbon-rich compound mixed with water ice. So that is actually very interesting. Then we can see what actually this carbon-rich compound come from. Does that link to a previous life possible on Mercury? So this is actually give us a lot of information for us to explore Mercury even further. But for now, you can see definitely Mercury is not a habitable place. I want you to take a look at the globe of Mercury. we will look at if you can see some significant feature on the surface of Mercury. You can see as the globe rotates, there's one of the most important feature you can even observe is a lot of craters, right? Tons of craters, big and small, the similar as surface of Moon. The other feature you can see on Mercury, there is a very large basin. We call the Claris Basin, actually generate from the impact. So you can see this is very, very significant. We'll talk about that in a little bit detail later. If you look at the surface of Mercury, which resemble the surface of the Moon, there is some low region represented by the dark blue color. Higher region represents by the red and orangish color, and there's a lot of craters. So therefore, Mercury, similar as the Moon, have a heavy cratered surface. There's also a very obvious feature on the surface of Mercury, which is Claris Basin. This is actually impact basin. This is the largest known structure feature on Mercury, and the smooth plain in the interior of the basin actually have an area of almost 2 million square kilometers. Now let's look at the video of Claris Basin flyover. You can see that is a map from, I believe, from Messenger spacecraft. Once fly closer to this basin, you can see this is a very, very large area. Even inside this basin, there's a lot of craters, right? You can see it definitely get a close look. You can see also the surface indicates there is some like lava flow or some liquid part of the surface is used to be kind of the liquid lava. You can see this kind of ripple represents the possible lava flow in the past. There's a lot of small craters on the bottom of the basin. As you can imagine, the scientists think about what actually result the Claris Basin. We think about is a huge kind of impact from a big asteroid that actually creates this Claris Basin. Other than the crater similar to the Moon, Mercury also have a kind of a unique feature. You can only see this feature when you get a close look at the surface of Mercury. If you look at it here, looks like there's long scarps. Long scarps is like a cliff on its surface. And this is something, it's different from the cliff on the Earth. We believe this is not due to the plate tectonics. As well as similar as the Moon, we believe there is no evidence of plate tectonics on the surface of Mercury. And we think about how these long scarps, or if you take a close look, it look like cliffs, is actually due to a global compression of Mercury crust during the past 4 billion years. I actually have our example to help you understand better why these long scarps can form on Mercury. And if you look at these two apples, this is a healthy apple, and this is kind of disgusting rotten apple. You can see what's the difference between those two apples. Of course, if you put apple outside for a very long time, inside of the apple will lose a lot of moisture, right? So the inside of the apple will begin to compress, will begin to shrink. As a result, the surface will start to form a lot of like the folds or the wrinkles of folds. And we believe that the similar like these folds on rotten apple, we believe they're long scarps on the surface of Mercury are due to the shrinkage of the interior. So therefore, the interior become compressed. So therefore, the surface left with a lot of fold. And if you look at the overall speaking, the Mercury, we believe the mantle core is much larger, much significant than compared to the Earth. However, its mantle and the crust together is much thinner. So we actually believe that early in the evolution, the Mercury looks like it's apparently lost part of its silicon mantle due to a one or even more giant impact. So due to the impact, a lot of part of mantle or crust just become debris and fly into the space. So therefore, we believe that might be the reason that Mercury actually have much thinner mantle plus crust together compared to the Earth. That is pretty much what I want to talk about for Chapter 9. For Chapter 9, we first talk about the general property of the Moon, and we talk about the lunar surface, the feature, and in much detail we talk about the cratering, how the crater forms. Then we talk about the giant impact hypothesis, which explain the Moon's origin very well. And after that, we talk about the general property of Mercury, the surface feature of the Mercury, and as well as where all these features like a long scarp, porous basin, as well as crater come from.